So I'd like to briefly introduce Professor Kong. So we are very delighted to have Professor Kong as our guest lecturer. So actually for Professor Kong is not only a very successful entrepreneur but also very good engineer. He has many patents and many publications in different domains. So Professor Kong received the Master of Science from our university, CityU University. And also he received the doctor from our university in automation system and engineering. So he has published many articles in different journals. His research interest focuses on robotics, intelligent manufacturing, automation, maglev technology, robotics, mechanical engineering, electronics, and system engineering for industrial factories. So he is very famous, like the entrepreneur. He has led Broadway Precision Limited Company, Eagle Nice Limited Company, and Bloom's Technology Limited Company. And he has received many patents for automated machines and instruments in China. So in 2013, he was an executive director of Automatic Manufacturing Limited company. In 2019, he was a chief operating officer at Wanling Optical Factory, and currently he is a modernization director of Eagle Nice Limited and vice president of CityU Engineering Doctoral Society. So today, Professor Kong will give us a talk on his work in smart manufacturing and some important applications combined with our course materials. So let's welcome Professor Kong.
Thank you. Thank you, Professor Mang. Good evening. I would like to present myself and working in the brick company. Also to hold a large team working for the industrial manufacturing, intelligent manufacturing, automation, robotics. And I have already developed a large machine in automation, including a large plants in China. Okay, I would like to share today about the guest lecture for the design for the manufacturing process and systems. Okay, this one. I want to talk about the topic for the how to apply the automation and intelligent manufacturing to design for the manufacturing of process and the systems. That's so important. After you graduate, you also study in the industry, and you also design how to make the automation for the machine and bring the success story to support also to get the benefit for the industry and also to get the value for you. Okay, let me introduce myself. I'm also the key speaker in the last years in the graduation for the year 2023. I'm also the key speakers also to talk about the graduation cemetery of the SYE department. I'm also the Vice President and Joint Doctorate Scientist, Senior Member of the IEEE, and also include a large also scientists. So below you also have the prize of the scholars in the City University of Hong Kong. Okay, and the next also to show you that in the last years I also have the keynote speakers to conduct the speech for intelligent manufacturing in the innovative Hong Kong forums with the China and Hong Kong. So I'm also to represent the Engineering Doctorate Society seminars, the keynote speaker, and conduct the speech for them as well. So I believe my value is also to share my knowledge, the practical experience to you. Not only academic, but also include the implementation for automation and practical, how to make your success. Okay, as a background about the intelligent manufacturing, as you can see the screen show, up today a lot of the automation, how the powerful solutions to meet our objective, relation for the manufacturing industry, and engineers explore the development for the automation for the manufacturing process and transformation impact to the various industry. Okay, so the first beginning, I would like to, of the you also to let you to have a think why we also choose implementation, the automation and intelligent manufacturing for the factory, for the shop floor. Why? How the benefit you think automation can help you? Okay. Anyone? So share whatever you wanted to ideas about the automation.
I think that automation will clearly benefit the production because you will have faster ways of achieving goals that you set.
Exactly. That's a correct benefit. Okay, firstly, your answer, your comment is correct because the automation also to bring the benefit to the company, also to improve the productivity, firstly, and also to enhance the quality. That's mean for the manual work, a lot of things depends on the operator. Mistake cannot be prevented. So we need to have the quality can be improved by automation. And firstly, is that as you say, the benefit for the high efficiency, more output. Secondly, also to the benefit for the quality. And the third one, we also to have the reduce the labor content because automation using the machine is such of the operator. So we also to have to bring three values for the benefit for the enterprise. Okay, the next one. The benefit we also to have the quality, increase the productivity, right, and improve the quality control, and also to reduce the labor costs because we can know that we can use our production and also to have the using the machinery, also to save a lot of the investment, save the term of the labor. Now in China, a lot of country, including Vietnam, Cambodia, and China, they also to using the one operator to operate two machines of work in parallel, so that we can reduce the labor hours. At the same, we also enhance the safety. If the machine can be made perfect, safety can ensure that some of operation, some of operator running for the dangerous job, for example, for the melting, for the another job will be easy the machinery to be hurt for the operator. So machine, automated machine can prevent if any accidents. So actually, we also should have to know the automation in manufacturing. We're talking about the hard automation. What is the hard automation? Can we also to show you that we also to using the different types of automation technologies in manufacturing, just on robotic, machine vision, artificial intelligence, the IoT, the application and contribution to streamline the production process. Okay, the next one I want you let me to think. If we can talk about the hard automation, all of them you know you learned before the automation. What is the soft automation? Any idea? Soft automation. Yeah. The soft automation, we talk about the digitalization. Using the system can be integration to the manufacturing facilities. Okay. The soft automation, we talk about the digitalization. In automation, just like the production planning and control and how to make the scheduling for the production. So the automation can add to the production plan and control. So actually, for example, in the industry, we also talking about the inventory control. And as you know, I think you have learned a lot of the knowledge of the inventory control, right? But you also to learn how to make the managing the production shop floor, include the production resources, operation, and minimize the downtime and improve overall efficiency. So as of today, I would like to let you to know the automation. You can see the robotic and automation using the machinery to work on that as well. But we also to have the soft automation. Soft automation, as you think, you also can use in the systems, just like the ERP system, enterprise resources planning systems. From we receive the production the orders from the customer, the system can plan what the materials we can use. And at the cross, we can contact about the production materials like show PMC and planning to your cars. So we can think, we can use our big mobile handheld and also to have the apps to see the production line, how the status. And you know a lot of import data can show you how can you manage the production in using the digitalization, the system, using the monitoring, all the production. Okay, the next one, I would like to introduce the lean methodologies implementation, the design of the manufacturing process and systems. Okay, so have you listened before the lean manufacturing? Any audience can have a comment? What is the lean manufacturing, lean thinking? Yeah.
Yeah, better way to organize the production line.
Okay, one of the organized production line, another one, and any comments where you think about the lean manufacturing? What's the lean manufacturing, lean thinking? Do you know what is the meaning for lean, LEAN? Well, the lean, that means the using the minimize the resources and shorten the lead time can produce more and more output. The lean also to bring the benefit. Using the tighten, automate the resources can also to put more and more output for themselves. So that's the lean manufacturing for themselves. Can I? Okay. So actually, we also to think about using the lean manufacturing, lean thinking. The lean thinking and the lean manufacturing is the one of the three. In the lean, also from the Toyota, just like over 15 years before, Toyota also to make the cars also to using the lean systems, lean thinking. What do you mean the lean? We also to using the system, using the methodology thinking, using the lean methodology to apply for the manufacturing. So we also to talking about using the one of example. We also to using the lean methodologies for the garment modernization. It will involve the lean concept of the modernization, digitalization system on them spec. Okay, I would like to introduce one of the methodology. How can we also to make the lean methodology on the manufacturing modernization? That's mean the automation. Automation, do you know in the automation, what is the step for the design of the automation for the factory? In the mainly, we need to design the automation. Firstly, we need to make a study, the requirement. For example, in the factory, we also do a lot of work is the manual for the operation. Later I can show you. The manually showing for manually the upload and download and the final process. What different requirement? We wanted to make the automation without the operator, the loading, unloading, up and place, and automatic to let the machine running. Finish the semi-finished part or the finished part can be made the qualification. The product can be passed to our quality control. So we think that how can we apply the automation in manufacturing? Firstly, we need to define the requirement. So we also to define the requirement for them as well in the design of automation. At the same time, how can we also to using the lean methodology bring to mix to the automation design methodology. So we can be using the lean methodology on this well, define the value and the requirement study. What is the value can be get the benefit if we also apply the automation. Just today, I'm talking about more of the automation. Let me you know automation, what the benefit we wanted to do the automation. What the value of the automation we wanted to do. At the same, we also to define the value. How can we define the value? The value to say we can save the study time, just one of the benefit, and also to shorten the manufacturing time, bring the value, say as the high productivity, and also to have the quality control. And then we also to explore, let me show example for this for the garment industry. We're talking about garment. We also to have the explore the automation to the sewing operation. Okay, I take the few example for the garment. A lot of people also to using the single needle machine to also for the sewing. Okay, now we also to working for the automation using the automatic temperature machine in such a manual sewing for the jacket for the garment commodity. So we also to explore which automation will be help to get the requirement. Okay, for example, for the sewing, we also to explore the sewing machine. For example, in the industry, for the electronics industry, we explore using the print-based machine and surface smart technology, and using the print and place the SMD comparison to the PCB board. So we also to bring up automation to inverse to be replaced the operator, right? So we also explore a lot of technology, machinery can bring up the automation for the specific operation for them as well. And then we also to select the best solution of the automation for the shoring operation. That means, for example, we also to have not only the single automated machine, but also maybe using this type automation machine, and we have any alternative. Maybe using the pen-based machine for them as well, but we can change using the hanger systems and the automation machine, and maybe also to combine the two operations together and using another automation machine. We can find the best way, best solutions. So we also for this one, we also develop and build and test the hanger line system as one of the best solutions. For example, the requirement is the sewing, the manually. And we also propose the solution for the hanger lines. What is the hanger lines? We also using the hanger system to move the one of the jacket to another jacket, to another operation. So using the one to another conveyance line to move the PIP from one operation to another one. So we can how to make the build and development and test the solutions for them as well. And then we also to apply to the lean also using the railway speed mapping. We also to map the current state, the VSM, for railway speed mapping, and then we also to make the future railway speed mapping. So do you study any course to talk about the lean manufacturing before? Do you know what is the meaning of VSM? Yes or no? Railway speed mapping? No. Okay. So you also the latest. We also to provide some information that you to have the understanding how to build a chart to study at the beginning of the operation to do the end of our operation. We also to have the methodology using the VSM. VSM also to map the each operation, the standard income, output, and also to involve the number of operators and machinery. VSM is one of the tools in the lean manufacturing. Okay, you can search information from the Google and also to maybe the course will also to provide the tools to you to enable you to know what is the VSM. And after we mapping the current and the future, we also to build the workflow and also to looking for the capacity requirement planning. So, do you have any study for the capacity requirement planning before? No. Okay. So that's for you. That's the new technology that you to understand in the bank. Okay. What is the capacity requirement planning? You can also to search the article. Also to publish for them as well. In the capacity requirement planning, depends on the arithmetic calculation, each operation, the throughput time, and the output. We can find the bottleneck operation. For example, operation A, B, C, D, E, maybe the operation B, the output is the lean for them as well. All the operation, for example, have the 10 pieces per hours, but the operation B in the middle only the 5 pieces per hours. So we can catch up the bottleneck, the operation, and then we calculate how can they make the automated for them as well and improve the output. Once we also to make the automation, operation B will be increased 2 times, 3 times, but another operation cannot be provided WIP for them as well. So the capacity requirement planning should be the allow you to know, calculate all the capacity output from each operation, and then let you to know the line balance for them as well. So another lecture, we also be talking about the CRP, how you run the CRP for the operation. So for the automation, you can see that not only to build the machine, to make the automate, will we get the benefit, but also you also to take care. Any the variable you can to get the brain for them as well. Secondly, we need to know which automation, which strategy, which the best solution can you select for the operation we wanted to improve. And secondly, we found how to build automation, implementation, this automation machine, and how to replace operators, and then how to let the operators to understand using the machine, the training, and the operation, how to pass through the finished good for your operation, and then you complete the operation, the worst piece, and then pass through the downstream operation. So that means that also to understanding the whole flow. So at the same, we also to using the lean methodology to using the know which bottleneck the operation need to improve. We improve the operation B, operation A, and then operation D, continuous improvement. So that's the lean concept. Okay. So for the workflow, we also needed to define the whole manufacturing link. You can find it. There's not only the one operation can be automated, so you get the benefit, but also you improve the operation by automated machine. You can define upstream operation, downstream operation, may not to have the line balancing for them as well. So the capacity planning is required to plan the demand and the particular output ready to meet up through the water line balancing. Okay. The practical, we are also to have the case studies videos for various industry in China. So I think that a lot of theory are so important to you. Okay, next one also to see the video. Some is a video is some is with the China script. Okay, you can see it, that's the e-board. Also to show the production output, the order quantity, computer the term for each operation centers. You see the workshop also using the AGV, also to move the WIP, the metal parts, from one side to another side. Okay, that's a real case. The suppliers also to take the photo record for them after the machine, the showing something, and the milling, catching the purpose from one operation to another operation. And the AGV, that's a robotic machine. Hand carry also the same from one operation to another one. Okay, you can see that we also apply the rubber arm, also to put the bend place the metal parts to the machinery. And at the same we also the e-board can show the performance, the number of the output, and the manufacturing status for the production shop floor. So the robot arm also to using the machinery, the robot to bring and place the materials into the machine and unloading for the machine. So you can see that you can using the AGV also to take up the rubbish to another shop for the work center. Particularly, we are no need to using the operator to switch off the lighting. So another one you can see that we also to have the WIP, also to have the braking on the and the moving to the pallet. The robot arm also to can be put the pallets to one side and the right the another side. And then to notify the AGV can be correct and move the WIP from one workstation to the workstation. Today I would like to show you that in the metal finishing, the workshop, we also using robot arm to running for the routing, showing, and put the machinery, the machining. So that we can see the robot arms, they're also to bring and place the metal parts into the machinery, and then correct the metal part to the pallet. At the same, you see the product is supposed, and also to have the e-board to show the each operation centers, whether using the robot arms and testing machine for the manufacturing status, whether the alarm operation or any problems. I just finished the video. Do you have any comment for this case? To help you to understanding how to apply the automation for the real case. You have received a lot of alarms. When you ask the question, how to design the automation for the manufacturing? When you also to think, how can we using the e-board to notification for the operator for what? When you also to ask, why can we design the whole systems? It's not only the robotic arms, but also have the electronics block, and also too, how can you set up the automation for the different types of the part of the materials? So, to let you to any thinking, when you have any ideas, many comments or any question, you just bring, can ask me. Question? 讲中文可能好一点点咯。我想问一下，这里刚刚看到现在的自动化的东西都有他们的用机器手在这里加来加去的嘛？加来加去的时候，你看到这里为什么你这样做这样这么好处？还是你这样做的时候，我们这里看得到出来有什么的设计出来的东西，可以给我们这里做一个建议基础的。 I would like to understand in the Mandarin talking about how can we decide to using automated machine for the how can also detect the play in place and why we also can using the automation machine to apply for the various products for them as well. At the same time, we think automation, how can we make the implementation for them as well? Why we also think using the e-board can be on the shop floor to show to the operator. Why? Just like the interest question, let me define.
Well,
Question, yeah, we also define your comment.
it's like if you have to implement automation in some place where there's already some form of manufacturing going on, then you can't. It would be a waste of value to just redo the whole thing. So you like implement ways where it seems like, oh yeah, we can have this car going forwards and backwards instead of a map. Because making a transportation system would be much more expensive.
Yes, but actually we also need to talk about the return of investment, the ROI. Well, actually in the practice, our industry, we also need to talk about invest the machinery for them as well. And investment is very high, $7 million to working for the automation machine. At the same, we also calculate the saving the operator. The number of operator can be saved, maybe 10, 20, the labor cost. At the same, we also to save the output. For the laundry, we also running the operators just like the one shift, one time with the outfit charge. We'll also choose 8 hours to 10 hours. But in the automation, we also choose let the one collection can be managing the operation for them as well. Even as we also the on and off, we also choose using the machine to the AGV to bring the very progress for them as well. So we also choose can we get the benefit as we reduce the operator to moving from one station and that station. For example, we also to moving the pallet from the lower floor and then put the escalators to upstairs, upper floors to find another workshop. Using the AGV will be much better. They will also do not to stop for them as well. Can receive your orders to control of the matters. So actually we will make the implementation. We also to define the value. Say after automation is very high cost, but actually the ROI maybe the 2 years, 5 years. Normally we have set the 3 years to the 5 years. For more than 5 years, we have to think we have any additional values for them as well. For example, very cheap operator, the labor cost 700 cents to be placed for them as well. But how can we make the operation is a value for them as well? Some is a very cheap the operation. Well, the cheaper labor cost we expect for these years the labor cost very cheap. Automation, the machine is $1 million, can be replaced 5 to 10%. 5, 10 the operator, the labor cost cannot be afforded to the automation. Maybe the return of investment to 2 years, 3 years, maybe 5 years, up to 10 years. So that's a very, very important to let you know we get the value to support for them as well. But for the automation, there's not 100% will be high efficiency, but because we also have a changeover time. We also change the changeover time because we also set up the machine for the automation, and then we also retune the machine to shoot for another operation for another products. So we need to have the technical engineers to be able for them as well. Normally, we also do running just like the automotive, just like using the car industry and our media industry. They will also choose running the automation machine because they will reduce the labor content, labor force. Work for another country and working for the aluminium factory. They also to very big machine. The worker only do 2 or 3 workers to move the brake or medium metal parts to the machine up and down. They will wasting the time with 2 hours. But using the robot, 20 minutes. So you also to make the comparison. Sometimes our operator, few of our operator, put up the brake metal, the inside metal machining, and then sometimes will be damaged the machine because the wrong position, the crash, not safe. So using automation machine to prevent for them as well. So you can think that if in case we also using automated machine, the robot should be put the aluminum materials into the machining for the injection machine, something like that. We also to save the labor cost and the labor content. What is the labor content? A lot of the customer, just like the Nike and the big name GM, Apple, they request the manufacturer needed to use in the automated machine. It must rather than the manager because they will consider will have accident. The labor is over the labor content. For example, take a lot of force to move one and another one. Automated machine will help them. At the same, we also to control to know the actual output. And our manufacturer are also to working for the Apple to using the metal part for the aluminum frame for the Apple manufacturer. So we also to ensure the daily output, hourly output, the number of the day, the quantity can be shipped to another operation centers. So we need to ensure the robotic and the automation machine can provide the output in the past due. For example, past due also to the less than the over 97 to 99% pass. The failway just less than the 1%. We ensure the delivery orders can be shipped to another operation on time. That's a good thing into using the automated machine. But we can know the investment is very high. Okay, I'll show you another real example. Okay, there's some example also to show you the practical for himself. You can see the using robot arm for the planing. The plating, you see that we also should have this areas is a plastic part, maybe the metal part. We also display the coating for the product. Okay, if you can think that a lot of factory are managing while using the operator to put the using the spacer, the spray, the printing and the coating for the metal part. Sometimes the operator can be aspiration to take up the action for themselves, they're not happy for the operator. They're using automatic. You can know that's very even. To spray the coating on the metal part. Okay, show that's a good quality. And the other one, we will not much to raise the coating materials, the spraying. Okay, another typical one is the welding. So you can see the robot arm also to have the welding, the spray for them as well, for the metal part welding. In China, Indonesia, now they also to have equipped the robot arms for the welding. As you know, the welding is not performed by the robot arm. You can see that the welding result is no good. Yeah, so that's the quality control technology can be made a stable output. At the same, the metal parts be to use the robot arms. You can ask a question, can we also choose using the menu, the routing will be cheaper than the robot robotic machine. Right, you can see that, but the quality is no good. So you can see that a lot of the electricity mobile and the electricity car, we also choose using aluminum film to using the welding, the robotic welding solution. Okay, another one is also to say that the robot arm for the upload and unloading. For the rolling to the machinery and then upload to the machinery, we're using the robot arm to perform the job. Why we can use the robot arm to this? Actually, we also to reduce the set down labor time with the request for the machinery for the machining. At the same time, we also to have the job infrastructure to design for them as well. So there will be change the work center and the base can be changed. Robotic arm also support for the change of the base can be maximize the output. Okay, that's all typicals. We also to suppliers also to have to miss the video for the loading. In the China, in our larger factory, we also to using the robot should we make the cartooning. The cartooning is not a very high job. There's also to using the robot, but also to make the packing and continues the line to put the cartoon on the pallet. The pallet is ready for the outgoing. So you can see that we also to show the demonstration. A lot of factory we also to have the product guides for the robotic. Because robotic, some of the very heavy, easy to also to crash for the operator because robot arm is with no eyes. Long range just perform the job. Okay, just for safety for them as well. Okay, and the next one I would like to show you how to apply the automation robotic arms for the metal industry. It's using the AGV also to pick up the main progress from one operation and moving to the metal shop. So the latent AGV also to pick up the product and the robotic arms also to hold the metal parts into the machinery. That we're also using the robot arms to pick up the metal parts, finish the machining. And they put on the trays for them as well. We call this one is the robot, the latent robot, the AGV. AGV also to have the program for them as well to go to the another required station. This programming of the AGV and managing the AGV also to make the cooperation with the robot arm. So in the intelligent manufacturing, we also to consider how can we finish the latent AGV task and then to tell the robot arm to take place. So you can see that we also to have a machinery, finish the machine and then let the robot arm to break the product on the pallet. How? Why? We also can let the intelligent manufacturing. How can we do it? We also to have the sensor to control the machine to finish the signal with the robot arms. The robot arm using the PLC to control the robot arms to pick up the metal parts to the tray. show in the China, the sort of the factory from the China. So we also should have the HUV put to the empty tray from the one was and another one for the return. So after the return, the HUV also should do the another job. You see that the HUV is very busy. After that, the HUV will come back to the position for the electricity recharge. Okay. After you see the video, you see the very interesting robot arms, HUV, and think and decide how can we make the design the HUV to the production shop floor. Firstly, we can think the HUV system can make the cooperative for the robot arms. As you know that for the robot arms finish the finished part, we need to how to make the control tell the HUV to come here, take up the product out. You see the video is very easy. Come here, very interesting, can do it automatic. But we need to consider how to design. For the cost for the design of the manufacturing process and systems, we need to know we need to know how to make the designs for them as well. Firstly, we also to make the methodology, and then for the technical part, we need to have the robotic arms, okay, and then how to pick up the work in progress, and then make the integration to the HUV. Okay, I come back to the video. Let me just see the water technology inside there as well. Okay, firstly, I stop the screenshot from there as well. Only let me to know unlock your injection molding machine and machining bring to apply the robot arms. Right, that's the real situation in China. Unlock your factory, the top tier, the working for the metal part for the supply to the Apple, Nokia, and the famous man also to apply the automation. Secondly, you can see how can we make the order for the latent HUV to put up the pallet to the shop floor. So we also to have the systems, also to make the cooperate the HUV, the latent HUV, to understanding the signal from what? From using our IoT, the Internet of Things, also to using the 5G to provide and the Wi-Fi the signal. That the latent HUV to receive the orders due to the operation, the status controls for them as well. Later, I will show you how to do it. And on the other hand, we also choose the robot arms. Robot arms in our industry, our factory, we also choose using programmable, using the PLC to control the robot arms. How can we do? Give them the signal to let them to work, to pick up for any areas. And we also to have sensor to let them to know the condition and then to do another job. Okay, so we also do the hardware is also to have the fixture or the holding the grip and the materials. Okay, we also make the standard parts 6. And the later nature we also to pick up the parts from one operation to move another operation. So we have to define what the HUV can be, the loading, can be handled the loading. The how rate we need to use in the HUV can be used for them as well. A larger HUV can have the limitation. For example, moving the metal part, that's all right. Moving the very heavy, over 1 ton, the metal parts may not be okay. Well, depends on the weight requirement. We also to select which kind of the HUV to support for them as well. Compared to the methodology, we also should let them to know what the solution we wanted to do. So for this time, maybe also to let you to have any question. We also to brainstorming. If you are the designer automation using the HUV, what do you think the consideration for the actual operation? What do you think? How can you design? Open question. What if you are the designer, design the automation for the shop floor, for this case, okay? What do you think? How can you design? May you also to design the requirement, the think using the HUV, using the robot arm? What do you think? You can say.
I'm wondering why we use AGV instead of using a belt line to transport the product. Because I think the belt line will be more efficient. Because AGV can only transport one item each time. But belt line can keep continuously transporting.
Right. So, any idea? I can answer your question one by one. Okay, we usually just think about using another solution, conveyance line and maybe the magnetic electronic slice, and can be to moving the passport as well. Okay, so I'd like to show you why we're using the latent HUV for the metal parts. It is because when we design the conveyance line, we need to ensure the width of the conveyance line. Okay, for example, your metal part maybe the small one. You design the line will be here. But sometimes I receive the orders have the using the metal part. From the original one is very small to the critical one. So we will change the product line so the conveyance line cannot be successful for them as well. So we can say the feasibilities. A lot of the shop that's not only the one thing to build the one product, they also to change from the small one. The next one will be the big one, only one piece, and then step one piece, the latent machine to move another one. So using the conveyance line is only to concern the particular areas specification requirement for them, not feasible. Conveyance line, that's one thing. Just only the same speed. You know that? Also same speed. Maybe say the 5 minutes per second. 5 minutes per second. To take one. And we cannot to say if the machinery down, we also choose let the HUV to change another machine. Conveyance line maybe the comprehensive setup if the machinery down, and conveyance line to decide to move another line to another one. So the conveyance line is very easy for the another logistic systems. Okay, any question? That's good ideas. Good ask the question. Anyone?
Is there any about the safety issues about this AGV?
Sorry?
Is there any safety issues maybe happen in this AGV? Safety.
Okay. Actually, the safety issue for the HUV, we're talking about actually using the HUV can using the labor also the same corridors, but sometimes will be crash. Okay, but actually using the HUV is not so good for the manufacturing shop because the labor come here and the HUV will be crash, will explode. The automated machinery can run the automation, and the second phase using the HUV for the transportation. So I mean that for the whole center, we plan using the automated machine programs for the machinery. Okay, the first one you complete. You think the second phase using the HUV to be plug and place the parts from one operation to another operation. So we also actually in the factory we also should have the one of the corridors for the HUV and operators and other areas for the maintenance. Separate the corridors. So in the later I will show you the warehouse how can they apply the HUVs for them as well. Any question? You can define the design, if you are the designer, design automation for the metro workshop, how can you think what is the first one? First one is the study. What to vary for the change from the manual job to operation. Secondly, we also define what is the best one. For example, the one of our smart guy also to think command line, AGV, and maybe another solution can be how to make the best solutions. Okay, that's a very logic. And the next one, the what kinds of the robotic arms should suitable for the manufacturing. Some robotic also to pick the metal part, pick and place for machinery. Some of the robots using for the welding to apply for the coating, spraying, and machinery. So you can define the robot, what you order the robot to do. For example, and the upload and the download, that's a very, very low level. Because, for example, using the IC is a very high standard. Using robot arms and then put another side. They're also using the visual screening, the camera, to see the plane and place. In case of the plane of wrong position, the camera also take the screening and then tell the robot arm to make the adjustment. That's the value inside of the operator. So our involve the operation in our China factory also to have a robot with the visual screening, some camera, using the eye and the arms together. And then the moving the whip from one solution and that solution, it can apply using different models, command line, hanger system, data HUB, and some respiratory, something like that. Depends on the actual requirement. Okay, and we would like to share with you the summary for the applied lean manufacturing, just like for the garment for them as well. We also to say study the requirement for the lean requirement and the manufacturing process and bottleneck process applied for the intelligent manufacturing, improve productivity and output. So a larger garment, the factory, is not only to depends on the sewing operator, we also to try to use the measuring machine or the metal machines for them as well. And we also to cooperate broadcast industrial manufacturing machine for the solution provider for implementation methods. Sometimes you think you are engineer, you think to using this manufacturing solutions automation. At the same time, you can search to find a way the best suppliers to provide the intelligent manufacturing solutions for you, for your company. Not only your engineer to think how to modernization, how to do it. You can write the best solution from the outside plus to them. May you continue to adopt to the lean VSM and capacity requirement planning to know to resolve the bottleneck operations. What is the bottleneck operation? For example, the bottleneck operation, maybe the one operation is a critical minimum output. But after we solve from the minimum output, for example, the first one time 10 times, okay, we solve. And the upstream operation will be the bottleneck. So you need to find out which capacity planning to make the line balancing. Otherwise, at the end, the output finished good cannot be achieve the more production outputs for them as well. Okay, latest, we like to have the data stream warehouse that brings the power of the digital logistics. So I would like to introduce another method, how to use the automation, the machinery for the warehouse. So the system to use IoT, have you understand what is IoT before? Internet of Things. What's the Internet of Things? Yeah, example. What's IoT? For example.
device connected to the phone or the.
No problem.
Like the recent air conditions, they will using the apps to connect with the apps to turn on or turn off outside the home and check the status of the device, the device that you control or something like that.
Okay, you also do think about the IoT application. Okay, any ideas? Interactive. Any smart guy wanted to speak anything? Yeah, the top. IoT was the minutes for them as well.
Some sensor can monitor and cloud device monitoring its status, and then send the data to the cloud and collect them, and put some device in connect to the cloud and do some things to take care of that.
Yes, they're talking about more for the architecture, for the, how to make the IoT. That's right, because from the sensor to take the sensor some information and output, and then send to the cloud, say as the using the 5G, using IoT. IoT also related to the devices for themselves. So like the VOSA and just like the 5G can be made the connection. Yeah, that's a part of the answer. Okay, so actually, we also using the IoT. You mean that I'm not sure. You also know the AI. Okay, AI. I think that's a big topic. Now is a lot of people talking AI. I'm not the expert. I cannot tell you more the AI because you say that using the computer vision. Show that one of your customers also to talking about some sensor, something like that, and then to capture for them, right? Correct. We also choose sometimes using the computer vision. Computer vision includes some cameras and compare the product, compare the picture, and then that you to know there's a normal. So that we have some computer vision and the smart sensor. That's also to say that the smart sensor, that we should know the electricity sensor, motion sensor, and some optical sensor. You want to know the body has not been the placing on place. So we also did not what equipment to achieve the full automation for warehousing by outline control, remote monitoring, temperature management, and goods in the warehouse. So actually we also using the software, okay, the software operation and related to AI, IoT. It's the digitalization related to automation. Automations for what AGV and robotic arms, the running for the warehouse. Later I show you. Okay, this chapter I would like to introduce the three kinds of the AGV for the digitalization. Okay, for this one, sorry that I will not only the Chinese but the English version is so long. They will also to have the sensor in this forklift AGV. We also to have the sensors for them as well, and also to make the connection to the cloud in the IoT. So that using the forklift AGV also to take up the pallet from the one position to another position for the warehousing. So we also trained the AGV, also we call the AGV as the intelligent the tourist to using AGV. They also choose to take the AGV from one side and the sides. The later I will have the video to show you implementation the AGV and automated warehouse. So actually we also to know the maximum the roll is 210 kilogram, and also to connect to the local Wi-Fi and send and receive the brightness and number signals for the AGV, and also to running the light, the step the light up and the different colors for the different situation. Some of HUV also do have some color of the HUV. For example, the HUV also do full of the dangerous. We also do have the bright alarm. And normally they also do wake actually the green occupies the yellow. And another type of HUV is the latent HUV. This HUV normal is also do using the photonics, the sensors navigation. The HUV need to have the sensor to know what they wanted to go, their location. Very important. Some HUV also to have the sensor to sense the barcode on the floor to make ensure the location is correct. Okay. And then we also to receive the Wi-Fi signal to let them to know what the orders from the location A2 to location A4. A2, A4, you need to have the barcode that stick on the warehouse to let them to understand where to go. Otherwise, we have to make them programmable. How many lanes for them? 20 meters and then turn left and then turn right. That's programmable. So we also to have the alarm system for them as well. Very easy. We also do different kinds of the HUV support for the automated warehouse. Okay, then this one. That's the manufacturing process. What you need to learn in this lesson. Okay, there's the manufacturing orders to be received for them as well. And you also prepare the ASN around the shipment notice. To know what notice we also to get to receive the materials for them as well, and then stock in. Stock in now we also can launch of the factory using the barcode to know some materials from the operator, from the incoming materials from the supplier, and then we also do the labeling on the box. Okay, stick the label, very easy understanding. And then our quality people will come here to take the inspection of the quality. And then after the quality is good, for example, we ordered 100 pieces of the zipper and the materials, and then we check the number of the quality whether enough, and then scan the barcode, take the order receipt for the stocking. WMS is the warehouse management systems. We also needed to only the hardware, but the software we needed to consideration. So the system, they also to bring together from the hardware software. Software just like the warehouse management systems. We also to receive the information from the barcode and for the stocking. After the stocking process, we also to have the stock management for the stock take, and then to extract them for the load and unload. So at the end, we also to have the task management for the managing the systems. And then we also to have the stop out. For the warehouse stop out, we also to receive the orders. And then take the stop out, and then the labeling, and then take out the credits for the another one. So actually, this the warehouse management system include the stopping process, stop-out process, operation stop, and the reporting using the PDA for this one, and order management systems. So actually, using the ERP, we also can be provide the systems for the meta integration, can make the stop updaters to the middleware systems. Middleware system can be provided signal to the warehouse management systems. The warehouse management system also to pay the orders to the HUV, that's the warehouse control systems. So the warehouse control system in the feedback to the WMS, the warehouse management systems, and also to return to the center to know the order have been finished, the result and the return to the middleware. The middleware platform also to feedback to the ERP. So actually, we also can know that in the system, we need to have the ERP system, enterprise resources planning systems, a middleware system, warehouse management system and put the order system for them as well. WCS is the ordering system to give the order to HGV from one location and put for another location. After finish the operation, can also get the feedback to the warehouse management. The level 2 no done, and the level 2 the stop in increase the stop quantity, stop out to reduce the stop quantity. So actually, in the data monitoring system, we also to the what is it? This the warehouse the web. Okay, it's the web is for them as well. You know for example, this one is the 70 row can to which column to have the materials ready and then vacant. Is the materials ready, we can show the on time the information on the e-board. So the on time e-board, you can see that from the HGV, for example, for the start one and then this one, and the HGV also to pick up the goods from one side to another side. So in the digital monitoring system, you can see the warehouse. Is the wrap for the warehouse. You can see the green is available. The wrap can be placed on them as well. And you can see the blue also to loading for them as well. And the black also to the stop on there as well for the stop take something like that for them as well. You can use the different colors for them as well. For example, this one using the large of the color of the brand, let me know how to make this for them as well. That's the first layer, second layer, and then the layers. If you're running using the HGV running the warehouse, we can provide the digital monitoring for the HGV. The HGV also using this one have the job, they can pass through different areas to show the HGV is ready to the place and know and what the efficiency and utilization. It's an on-time monitoring approach to not the operator to know how we do. So the e-board, you can see that the HGV inside the map. That's the wrap for that as well. Show the logic is in case of the HGV to let the 08 maybe the 102, two of the order maybe 102 to go this direction and the 08 to go to this direction. Show the system needed to know their actual location and using the algorithm to know the left order to the HGV 102 stop and then let the 08 continuous and then the HGV 102 can be move upwards, move right, and then let the 08 to go through the ramp for them as well. So this algorithm in the HGV digital monitoring. So go live for the actually the HGV for the running, you can see that you can have the figures. For example, the cabin of the HGV 4 to go for this line upstairs. HGV 1 go to this direction. So the HGV 2 will have to receive the signal to move upstairs. Let the HGV 1 to across the road to another area. So we have the HGV needed to in the system with the algorithm to make the calculation. Okay, so actually the HGV also to have the implementation, we elaborate the guide of the map and obtain the HGV location information. And then we also assign responsibility HGV according to the task priority. For example, this priority is higher than the one. We will, the one is also this, and then the HGV 3 maybe take the slow the rating, let the one go, and then the HUV free, the one that is short. So also to say that to resolve the conflict, because we also the HUV would be have some correspond. HUV 4, HUV 3, HUV 1 will have the correspond the right color. How can we make reduce the conflict of the HUV? So HUV also to run the algorithm mechanism. They're talking about how can we let the HUV, which HUV can be take the first priority. It will be depends on the location, depends on the signal. Otherwise, the HUV will be crashing at the HUV. So for instance, we also be talking about the algorithm, to how to make the calculation of the root of the HUV to prevent if the conflict crash and the size. So a lot of the researcher and the designer, engineer, they think to create an algorithm to how to control the HUV from one side and the other side. If you have the designer, you are a designer, how can you also to resolve the conflict of the HUV? Anyone want to have any other ideas? For example, the HUV 3 and the HUV 1 will be crashed on the red bond. What do you think? How do you design the system?
Maybe give me a sensor and to detect is that maybe give me a sensor and detect is there any obstacles in front of it, and if there are something in front of it, it will stop moving to prevent conflict.
Okay, that's a good answer. Anyone talk about? Do you have any ideas if the two HUV may be crashed? How can you decide the route, the map algorithm to prevent the HUV to crash together?
We use IoT and make a cloud, and in cloud, it can know every car's position, and so in this case, the cloud will send the message like information to tell which car will act first, and then the second car will wait for update like that.
Okay, I would like to answer your ideas question. Okay, I remember your answer. We also taking yourself the sensor. Just before the HUV crash, the sensor will sense the this way HUV coming, and then assess you are here and then stop, right? Sometimes you stop, I stop, you stop, I stop. So you're rating, I rating. The HUV, so your mechanism is that you also to stop here. The rating for the one waiting for the signal. Okay, maybe you also to say that we have the sensor. Right, all the HUV we also to design the systems have the safety sensor, just in case that some human is very the set is very close area, we will ask the HUV stop. That's right for safety, correct. But for the algorithm, we also choose, your answer is also correct, using the IoT technology. We also to using the millisecond to receive the signal from the HUV. So let's say the 1 second device for the 1 million. We also to get the signal from the shorter areas. The calculation for the algorithm will make the decision making. Which HUV take the high priority and which HUV will be waiting for the HUV 1 across it, and then HUV 3 can be go forward. That's our algorithm tend to be. That's correct. We also to receive the signal for the brake system and then provide the signal for them as well. What is the priority? Sometimes when the priority are assigned the HUV 1, they take the high priority, but some hours have some abnormal case. For example, the HUV will be have the stop on these areas. The HUV 3 is never the waiting for the For example, the HV1 maybe stop here, maybe by abnormal machine area, machine breakout, maybe some error of the systems. Maybe the machine have some problem. So the HV3 will be breaking from the HV1. That's no. The system make them with calculation to know what the location of the HV1 and then change priority. Let the HV1 stop to know it stop, and then ask the HV3 go upstairs. So depends on the algorithm. So what we also did talk about the AI and the algorithm, and to think how the system to handle the abnormal situation in real life. If you can think it, you can decide the traffic management. You can decide a lot of the new car, just like the no driver, to also automatic car to take up all the operate all the other people to get this algorithm is very important. Otherwise, will be the system will be jammed. Okay, any question about the design for the algorithm for the HGV for the automated warehouse?
Would you design your map like by yourself in a system, or would you like let the machine learn about the map, the design of the location?
Firstly, because in itself the machine, we also to elaborate the map that basically in the system design for them as well. Which area is the route? Which area is a corridor? Okay, which is a conjunction point? Okay, the map is important. And the HGV also to using the sensor. Some is the see the location by the barcode. Some is the sensor the upstairs to know which location the HGV to place. Okay, correct. And then they also to compare the map and the HGV location to flow into the algorithm to know which HGV can we go forward, which HGV can we stop. Can I answer the question here?
Yes.
Yes, the map is very important, right? Every time the location need to know the map. So firstly, we need to map the map to get you to know where is the HGV. Sometimes the HGV maybe the system crash will also to reset. How can it reset? We need the HGV to know what the location is it. For example, the location for the 3.6 this area, okay. But sometimes will the HGV, the system will be maybe the lost the information, not the signal from the HGV1. How can we continue? Because we're talking about the IoT, right? We're talking about IoT, the sensor, and also to let the HGV send the signal to the cloud and something like that and receive the signal. But the HGV has some problems. How can we get the location from the HGV? So that's a good question. When they design the HGV and the mechanism, we need to know that level you right to be to happen in the real life. So we also to capture the latest status for HGV. If they bring up the signal, we also to try to connect HGV1. Otherwise, within the HGV1, further located areas will be bought, have the red patterns. So not allow the HGV password to open until we also to make the damage, the HGV take the alarm case to be fixed. Okay, there were a lot of technology, a lot of engineers were able to run the program for this one. Machine learning, can we do it? But algorithm, for example, for the machine learning, they will find the best, the travel routing for them as well, selective. But actually, a lot of cases, they can be detected. So for the machine learning and then the technology, for themselves, the HGV, normally machine learning also they're working for another application. Because this application normally using the comparison and the logic to know go and no go, and also the brake and stop and the running. Okay, I think that too will have answer your question. So let me to see the warehouse from the video our company. This is a private warehouse for garment industry. We're using the handheld to scan the barcode and stick the label of the traffic, the volume of the traffic. So the fabric will be automatic by the later AGV. That's not using the automatic for as well. After scan the barcode, we can know the location. Move it upstairs. Put the right position. And we also should have the HE board to show the which kind of materials inside as well. These are for the outbound. They're ready to move the fabric from the warehouse to ready for the pickup. Just a trim warehouse, accessory warehouse. What I talked about that there is the HGV, put the cross for that as well, rock curriculum. The HGV still activating for 0306. We also put the containers for the in-front to put the materials containers and to the warehouse. Scan the warehouse barcode. Which part will be delivered for them as well. But using the latent HOV, you put the very heavy of the carton on the product. The running across to the fabric. The HOV being using the forklift, the HOV, how then they do? We have the HGV navigation in the map. The HGV have the high precision to go here to pick up the pallet with the intelligent task operation. The HGV can make the integration directly with the control. Ask the regulators ready for them to put in. The CityU also to auto recharge the battery. Okay, that's our company also to bring on the automation in the warehouse. This is live. I show you the video. Now you can see it in China, it's not old traditional modernization. Even as the garment warehouse, we need to know what the operation being to run the applied automation for the industry, warehouse automation for the machining, and something like that. Any question?
Why would you use barcodes instead of NFC?
Sorry?
Why would you use barcodes instead of NFC?
Cost refactory. Sorry?
Why would you use barcodes?
Barcodes. Barcode, okay.
Instead of NFC.
Okay, that's the right question. It is because we also can identify that's the goods using the barcode. For example, we also to receive the raw materials from the supplier. Okay, the supplier will have their carton, and the carton we need to identify these materials, this box, maybe also to include the zipper. Okay, 10 bags. 100,000. So we also should have the box and also to using the barcode with the identification. This containers, this block to have the 10,000 of the zipper for the item A, B, C, D into the rack. So Actually, using a barcode is an identification for the product related to the carton, related to actual the raw materials, maybe accessory, maybe the work in progress, maybe the finished good. So we also do using the barcode, and sometimes we using the another technology, RFID. RFID is a radio frequency identifies the tip. RFID is very expensive, even as we also make, cannot be reused. The RFID will have some ideas will a lot of the finished good garment. We also to have the hand job to RFID. Just you think, if someone to steal the take up the goods without to pay the money, and of course the outside you will have the RFID, something like that, have the detect and the alarm signal to catch the work. So RFID also to identify the which product number, staff number, and identify numbers to let you to know. So actually, RFID barcode is so common for them as well. RFID have some area is disadvantage because in case of we have a lot of the box include the materials and RFID, the RFID detected whole areas, all the goods, to make the calculation, 10,000 the pieces for the zipper, for the trim, for the accessory, sum up all together. Sometimes we also RFID need to have to detect those areas. I wanted to separate the areas. That's not very easy because you don't know RFID can be detected. Detect this lot, maybe detect another lot, maybe detect another side. Not easy to make the control. So using the barcode, but the spend the time to scan the barcode for the materials, the stop in, stop out for the carton, and identify the goods inside the carton into the systems. Okay, can I answer the question?
Yeah.
Okay, thanks. Good question. Any question? Today, the guest lectures to provide to know, maybe to see the automation, robotic arm, how can they run it in the shop floor, into the manufacturing systems. And digital system, using the ERP, using the warehouse management systems, and control the HGV, control the warehouse, control the materials, and capture up-to-date information for them as well. So at the end, we also to have a lot of the technology of the automation from the solutions for them as well. So the first, they come back to the methodology. What the value we want to get the benefit from the automation? How much we make the investment for them as well, and the return of investment. Return of investment, not only can the productivity output, but also include the quality, include a lot of things. For example, to say the productivity, quality, and the labor content, and also to have the meta accuracy, the precision for the counting. A lot of the labor may not be very easy to make the counting, the number of the output in the systems. There are a lot of confusion. So using automation, also to mix to the digitalization, should come up to the whole solution for the manufacturing. We take the wheel for the industrial manufacturing. Intelligo using the IoT technology, let them to know what the signal fit and for to know what the location, what the system has. Right. We implement the automation also to think using the digitalization to linkage the hardware to have automation robotic arms. Do you have any ideas? Remember what I say? I emphasize the methodologies is important to know what the capacity for each operation. Just also to flex the bottleneck capacity. We also to continue to flex another one. So you can take the output for the final operation can be increased. Okay, so any question and answer? After that, I will, well, today have a lot of time, over 30 minutes. Yeah, to end the lecture. Any question? You can ask me. You can come back to slide 2, slide 1, and something like that, kind of understanding what we talking about, what the query you want to know, and what information you want to get more for your future, for your knowledge.
A few questions about the two sides at the beginning. You say that the robot can produce better quality of products than human labor. Is it always better than human? Because I hear that some skilled workers, they can do better work than robots because they are very experienced.
Okay, your question of the skilled workers compared to the robot. Okay, you count the robot as the maybe say the robot from the year 2020, you done 10 years before the robot, and the today robot, future robot. Okay, the robot operate also to the speed. Okay, the speed for the human for the doing some flexible things is very using the eyes, using the fingers to also do easy to do the operation for them as well. The skill operator is say that we also should take the 100 pieces per hour, but actually the labor will be have affected. Labor sometimes will help also to make the mistake. We cannot be right 100% operator come here, no mistake. If you mistake, they are punish. And they come back, no mistake. You know, just like the Fuji Hong. Fuji Hong also to say how to manage and operate the soul style from the Japanese. Because Japanese also using the new manufacturing when pieces fall using the operator. You know why? Because in the first generation of the robot from the Japan wanted to spend a lot of money for the operator, but actually you know that if in case we also the high mix low volume, the change of the different product within the heavy minutes, say at the 200 pieces, across the line change another style and change. So the high mix low volume can be the skilled workers can be very easy to using the fingers, the simple tools can do it, but depend on the skilled laborers. A lot of skilled labor after the poor economics, the laborers will become back to their hometown. We can recruit the skilled laborers that then continues to work 1 year, lasting to 10 years, very difficult. But for the robot, then the high precision control invest a lot of money. But in change of the program for the robot, you need to take time, change the fixture. So you change over time for the robot to change the automation will take the 2 hours, 1 hours. Now we also doing the first 20 minutes, upload the program, and the robotic can be changed for the different style, different product. So we also do prepare for our engineer. Take the 5 minutes, 10 minutes to change, automatic change. So before you also deducting automatic change, the manually to tuning the robot for your empty for the operation, you spend the time for this as well. Save the time for the robot in the system is so long, for example 1 or 2 hours for the skilled engineer. And then the robot can be continuous to work for 24 hours. But the skilled labor, 8 hours can be take a break, go to the washroom, just like you, also to take a break, go to the washroom and drink and eat, also to relax. Right, can I answer your question? Okay, thank you. Any other question? No question. Anything? Maybe last row of our student? No, no, no. Okay. Good.
And I think, what is the improve of IoT and the goal to improve the HV? I mean, is there any directions to improve it?
What is the IoT? Okay, the IoT normally we also do using the 5G and Wi-Fi. Some is the middle connection through the factory, but using the woofer also the IoT one of the terminology and the topicals for data connection communication between the I'm talking about the system to the systems. Yeah, because there's some limitation for the woofer and using the 5G now is the very fast and the better to middle connection. In the 4G, in the old communication, the technologies will not be favored for the automation. Up to now, 5G autom faster than 5G. They can make the connection for them as well. For if you wanted to interpretation for your question, some of the system we also do to build a lot of the router. Yeah, a lot of router in the factory, not the single router. Because single router we also consider for the 20 kilometers and then 100 kilometers and the square for this areas for one router. And then the router also to provide this for them as well. A lot of router support for the connection for the AGV and the robot to make the connection to the systems. Can I answer your question? Here. Okay. Any question? Okay. No, that's I will pass the time to the Professor Man. I'll finish the lecture. Yeah.
Thank you. Thank you very much. So you guys don't have any other questions? So are you guys like trying to look for some internship? If you do, you can contact Professor Kong.
Sure, yeah. If you have any interest, but also to leave my contact to the Professor Man and send the email address to you also. You can send the email to me, and if you have the link, any question in the coming future for your career path, for your maybe in the coming future after your graduation, and also to have to find a job, to working for the design job, engineer job, and technical job, you can have the good friend me. I can give some guideline to you. Maybe also to have some question after lesson. You can contact your Professor Ma and me, and can provide the good solutions and answer you. Let me you guys to know what about the intelligent manufacturing more. Thank you.
Thank you. Okay, I guess that's it for today's class. By the way, so just a quick reminder. So our the homework 2 is due next week, right? So it's originally this week, but I found maybe some people are having a difficult time on the midterm, so I give 1 week extension. But still, don't forget to submit the homework.
Okay.
Yeah, that's all for today's class. Okay, see you next week.
When do we get midterms?
So actually.